Hey folks, it's me again, and this time what I want to do is I want to go over a beginning tutorial on how to solve matrices. Now there is a lot of information, there is a lot of theory that I am not going over because my point in this is just to get you to do the very basic matrix operations, and as we move along I'm going to start to add a little more theory. That's just the way that it seems to have worked for me. So if you're looking for a lot of theory, this is not your video. This video is really for beginners, for elementary students who are just learning how matrices work. Okay, so with that in mind, let's go ahead and get started. Now, when we start with working on matrices, our primary objective right now is basically going to be to use the rules that I'm going to give you, transform your matrix into a reduced row echelon form. Now, reduced row echelon form comes from the fact that your matrix looks like a ladder. It kind of looks like that. And that's because you'll have ones in each one, like little steps. Okay, you'll see when I show you that. Now, that's our objective, and you always want to keep that in mind. Okay. Now, with that in mind, these are the rules, and there's really only three. Later on, we could spread them out, we could talk about other things, but the cool thing is, number one, you can multiply any row by a number. Number two, you can add one row to another, and three, you can switch one row for another. And you can use all three of these rules at the same time, which is cool. Okay, and finally, of course, these are the strategies. And this is just basically how you go about doing the reductions. So let's get started just so I can show you a little bit about how these rules are applied. First of all, let's talk about your initial rules. So multiplying any row, let's go ahead and assume we have a matrix here. I'm going to use numbers for now, or letters for now. And rule one basically says that we can multiply any row by a number. So for example, here you can multiply this by, let's make it more interesting. We'll multiply that by 2. And what that means is that our row will then be 2A, 2B, and 2C. Not a very interesting change, but later on you'll see there's other, you can also divide by 2, which is one of the big reasons we're going to do it. But at least I wanted you to see what it was that. You can add one row to another. Well, that one's simple. Once again, if we have A, B, C, D, E, F, and here if we add, and notice I'm using a notation, you should use these too, but anyway, we add row 2 or row 1, and I use Roman numeral 1 to show you that. Okay, what that means is that everything from row 1 is added to row 2 from each column. So for example, D plus A, and then you've got E plus B, and you've got F plus C. Your column number 1, of course, remains unchanged. So that's just A, B, and C. Now, make sure and write down some of these things that I'm showing you because it's going to be very important later on. Okay. Now, the third thing that you can do, and as I said, you can, by the way, mix and match these rules. So you can actually multiply and add a row. And that's actually what we're going to be doing most of the time. Okay, so we can go again A, B, C, D, E, F. And to switch rows, we just do this little double arrow like that. And that just gives us D, E, F, A, B, C. So, each one of these rules doesn't even look like it's very interesting by itself. It's once we start using all of these to approach our strategies, and we're going to have a couple of matrices we're going to work on. So, okay, now these are the rules and the strategies. Okay, what we want is, for example, we have a row and we have 3 columns and 3 rows, and we want to convert our column 1 into a 1, and column 1 and row 1, which is right here. Column and row 1, is always in the upper left-hand side. Everything else should be zeros up until usually we will have a final column. And here we'll just call that x. This will be 0, 1, 0, y, 0, 0, 1, and z. So this is our objective. Strategy 1 is saying that you want to convert your matrix into something like this. So for example, let's just say I had a matrix like this. Our first goal here is to get this guy here to become a 1. And so in this case, of course, our strategy would just be to, would be to divide this by 3, or we can do other operations. There's many ways to do it, by the way, just like in any math. But our point here, of course, is we want to turn this into a 1. But remember that whatever you do to a single row, you do to everything in that row. So it becomes 1, this becomes a 1/3, this becomes 1/3, and that becomes 2/3. Everything else stays the same. Okay, I'm not really going to go over that because we're going to do this right now. Okay, so, and the point is, once you've got that, then you're going to want to have another 1, and you're going to want to turn everything else into zeros. And you're going to do it in these steps, which is you're going to convert first. First, you're going to get your 1 in your corner. That's the point. That's step 1. Step 2 is you want to convert everything else into zeros. Okay, and once you're done, you move on to the next column, and you get your 1 in, here's column 2, row 2, and then you're going to turn all of these into zeros. Then you move to column 3, row 3, and you're going to convert this into a 1, and then you're going to convert this and this into a 0, so that it kind of looks like that. And in the end, you're going to have your answers here on the side. So let's go ahead and apply this, okay? So I started here with a little simple example, okay? So we have 2, 3, and 1. 1, 2, 6, okay? Now, right off the bat, the simplest operation we can do here is a row exchange, okay? And so what does that give us? It's just going to give us 1, 2, 6, 2, 3, 11. Simple, okay? Now, since we now already have a 1 here, our goal is to get rid of this guy here, okay? So what do? Well, in order to do that, we subtract 2 times row 1, okay? And what will that give us? Well, first of all, always remember, the row you're doing operations on, you start to change, but the one that you left alone, which here is row 1, you just carry everything over, don't change anything. One thing about doing matrices is it's very, very sensitive to any mistakes you make. And this is, as a matter of fact, where you're going to spend where you're going to sweat and you're going to cry, which is you're going to be making mistakes because as an elementary student, you're still not that careful. So this is why I like you doing matrices, because it teaches you to be careful. Because if you don't, you pay a very heavy price. This is very heavy. This is literally about, you probably prefer to get your hand slapped with a ruler than to go through a half an hour of a matrix only to realize you screwed up. But the pain teaches you, so okay, anyway, enough with scaring you. So we do this, and by design, this must be a 0, right? Because what we said is 2 minus 2 times that. Okay, well, let me just do it the long way so you'll see. So we're saying 2 minus 2 times row 1. Okay. And then this is 3 minus 2 times row 1. Okay, and this is 11 minus 2 times row 1. Okay, makes sense? Yeah, I guess I should move those numbers up here so that they'll all be in the same. You should be able to solve this. Let me just put that little line here so you'll see that these are rows and columns. Okay, and so what does that give us? Well, simple. First, we've got 1, 2, 6, and then this is 0, and then this is -1, and then this is -1, right? 11 minus 12 and 3 minus 4. Okay, now now we can change this into a 1. Remember that strategy by doing what? Well, simple. We multiply it by -1. Okay. And so what does that give us? Well, simple. First, we carry over the one we did nothing to. So 1, 2, 6. We've got 0, 1, 1. We're almost done. We just need to get rid of this guy here. Okay? And how do we do that? Well, we remove 2 times row 2. Okay? And so what is that? Well, we'll do it the long way again. Okay, so we say 1 minus 2 times 0. And then we say 2 minus 2 times 1. And we say 6 minus 2 times 1. And we carry 0, 1, and 1. And as you can tell, this remains, which is what we want. If that first column ever changed, we'd be in trouble. It's not supposed to change. Okay, so we say 0, 1, 1. Okay, and then we say 1. And then this by design had to be 0, because otherwise, again, we're in trouble. That's 0. And 6 minus 2 is 4. So this is our final form. Okay. As you noticed, really simple. But of course, I'm showing you the very simplest examples. So let's go ahead and move on to a slightly more complicated one. Now, be warned. Once we're moving into into these bigger matrices, your math increases exponentially. And what's really, really challenging here is your fraction skills are going to be put to the test. So if you're weak in fractions, you better do some practice, because this is just going to kill you with the fractions, okay? And these matrices, I've actually kind of made them right now to just give you simple answers. In real life, you know, your matrices are never going to be that simple. So let's go ahead and let's get started real quick, okay? So the first operation we do here is, I really don't, remember I already showed you this a little while ago, but I really don't want to divide that by 3. Remember, our goal is to get a 1 up here. Instead, I'm going to do it. I'm going to turn this, switch this around, okay? And so that's going to give us okay. And now, and by the way, I'm drawing out every step individually. Once you've done these matrices, you will probably be able to do 2 steps at once. so you don't have to draw as many. But just like with all other math, don't do multiple steps if you're not ready, okay? If you're still barely getting the hang of it, do it piece by piece. Take it slowly, okay? So let's see. Well, first we carry all the numbers that we didn't do anything to. So 3, 1, 1, 2, 0, 5, -5, 25. Okay, and this is 1 by design. That's 3 halves. And this is -3 halves. And this is 17 halves. Okay? Yeah, I know, and it's going to get uglier, so hold your horses. So now that we have a 1 here, our next goal is to get rid of this 3. And so we'll do that by just subtracting 3 times row 1. Okay, so, and I'm going to do some of the math on the side column over there, just so that we don't take up too much room inside of our matrices. Okay, so our first operation, well, first of all, let's carry everything over here. Okay, so this is 17 over 2. This is -3 over 2. This is 3 over 2. And this is 1. Okay, and then we have 0, 5, -5, and then 25. And we're looking for the answers to this, but already by design we said 3 minus 3 times row 1, so this will be 0. We already know that. Okay, so we're looking for 1, so that's 1 minus 3 times row 1, which is 3 halves. Okay. Now, you already should know that you cannot subtract two fractions until your denominators are the same. So I'm going to convert this guy here by multiplying him by 2 over 2. Okay? So we've got 2 halves minus 9 halves. And that's going to be minus 7 halves. Okay, so we've got 1 here. Okay, next one is going to be, we've got 1 minus 3. This is minus 3 halves. And so we're going to, since these are just by different signs, you know, we can just say 2 over 2 plus 9 over 2. And that just gives us 11 over 2. Okay, so we've got 11 over 2. Okay. And then we've got the last one, which is 2 minus 3 times row 1. And row 1 here is 17 over 2. And so, once again, we say 2 over 2. And 3 times 7 is 21. And 3, that's 51. So that's minus 51 over 2. Okay. And, wait. No. Let's not be careless. It's not 2 over 2. This is 4 over 2. Right? See, I was getting a little ahead of myself. I had to remember you multiply this by 2 over 2. 2 times 2 over 2. Notice that? That becomes 4 over 2. Duh. Okay. Anyway, well, at least I caught it early. Like I said, you've got to catch this stuff very early. Okay, and that gives us 47, negative 47 over 2. Okay, so we've got negative 47 over 2. Okay, so here we are so far. Okay, now what are we going to do? Well, notice this is all ones and zeros. So our goals 1 and 2, our objectives 1 and 2 are done. Now our next objective is to turn this into a 1. And you should already remember the simplest way to do that is by multiplying it by its negative reciprocal. So we multiply it by negative 2 over 7, right? So what's that going to give us? Well, I'm going to drag this matrix over here to give me some room later on, because we're going to need plenty of room. Okay, so the ones we did nothing to, we carried them over. 3 halves, 17 halves, okay, 0, negative 5, 25, okay, and then 0 times negative 2 sevenths is still 0. Negative 7 halves times 2 7 must be 1, otherwise we made a mistake. Okay, and then the next one, well, 2 over 2, 7, 11, that should be 11 over 7. And let's not forget the negative. Okay, and then 47 over halves, well, 2 cancels out, negatives cancel out, so that should just be 47 over 7. Right? Right. Okay, so now what do we have? Well, we have a 1 here, and we want to cross these guys out. We want to cross this and this. Okay. And so what's our goal? Well, to get rid of the 3 halves, we just say minus 3 halves of row 2. And we're going to do we're going to do both rows operations at the same time, just to save us some space. Okay, so we say minus 5 times row 2. Okay. And so let's carry that over. Okay, by design, okay, let's just start carrying over the numbers that don't change. And 3, this by design must be 0. This is 1. This is 0. If you don't know why there's 0, go and think about it very carefully, because otherwise you need more help. Okay, but now everything else, what we didn't change here was this guy here, minus 11, 7, and then 47 over 7. Okay. Now, we've got this so far. Okay, so we've got minus 3 halves. Let's go do the math here. Minus 3 halves. We're looking at this guy here. Okay, and then we say minus 3 halves times row 2. Row 2 is minus 11 sevenths. So keep track of this because it's going to get a little ugly. Okay, so this says, now since we have 2 and 7 down there in the denominator, I'm just going to multiply this by 7 over 7 automatically just to get us there. So that's going to give us minus 21 over 14. And then the other one's going to be 33 over 14. But look, minus and minus. So that's plus 33 over 14. And you should notice that this is 12 over 14. Which of course is 6/7. So this is 6 over 7. Okay. Then we say this next one. So this is 17 over 2 minus 3 halves times row 2, which is 47 over 7. Now, again, I'm going to save myself some time, and I already know I got to multiply this by 7 over 7 to get the same denominators, right? Right. Okay, so 17 times 7 is 7 times 7 is 49, 7 times 1 is 7, 11, so that's 119 over 14. If you can't do it in your head, do the math, do the workout, okay? I've been doing this so long, so I can't help it. Okay, and then 3 times 47, that's 3 times 7 is 21, and 14, 141, 141 over 14. Okay, and so that's going to be 22 over 14. Okay, and that of course must be negative 11 over 7. So we say negative 11 over 7. Okay, now we're working on the 5 here. Okay, so we say 5 minus 5 times row 2. So that's negative 11 over 7. And so once again, we're going to multiply this by 7 over 7 to get the same denominators. Okay, so that's going to be 35 over 7. Minus and minus is plus, so that's plus 55 over 7. Now, let's not forget though, this was a negative 5, right? Look, it's negative 5. Okay, so negative 35. So that's going to give us 20 over 7. Okay, and finally, the last one is we've got 25. So we see 25 minus 5 times row 2. That's 47 over 7. Once again, we multiply this by 7 over 7. Okay, and so 7 over 25, that's 25 to 175. Okay, over 7 minus 5 times 7 is 35. 235. 7. And the jump from 175 to 200 is 25 plus 35. That would be 60. So that's minus 60 over 7. Okay, so 60. Again, if I'm doing some of the math operations in my head a little too fast, at least you're following this. If you need to do the other stuff yourself, Never fear. Just please go ahead and do that. Okay. So now we've got these guys here. Okay. And so now, what do we need to do? Well, all we have to do now is multiply this times 7 over 20, right? To turn it into its reciprocal. And so what's that going to give us? Well, let me see. Do I have any more space on the paper here? Let me add some. We've got 1, 0, 6 over 7 minus 11 over 7. We've got 0, 1 minus 11 over 7. We've got 47 over 7. Right? And we just multiplied this by 7/20, so that's going to give us 0. Of course, 0. And then 27 times 7/20 by design must be 1. Otherwise, again, we're in trouble. Okay, and then 7 times 60 over 7. Well, 7's cancel out, and that's negative 60 over negative 20. Well, that's negative 3. So look, it looks like we're starting to get out of the woods. We got one whole number there. So that's good news. Now, what's the next operation? Well, we want to get rid of this guy and this guy, right? Okay. So the next operation will be, of course, to add 11 over 7 of row 3. And then for this one, we subtract 6 over 7 of row 3. Right? Right. And so what should that give us? Yeah. Let's see. Well, first of all, the row that gets unaffected is this one. That's 0, 0, 1, negative 3. Okay. And 0 plus 11/7 times 0, that's 0. 1 plus 11/7 times 0 remains 1. 11/7 minus plus 11/7 times 1 by design must be 0, right? Now the only one we care about is this one here. So 47/7, so that's 47 over 7 plus 11 over 7 times row 3, which is minus 3. Okay, so that's just 47 over 7 minus 33 over 7. And that's going to be 14 over 7. Which, quite obviously, is 2. Notice how everything's cleaning up now. Even though we had all these ugly fractions, you're going to see that a lot, okay? At least in the beginning. In higher math, nobody's going to be that kind to you. You're going to get ugly, dirty stuff, so just get used to it. Okay, the next one we're working on, of course, 6/7 minus 6/7 times 1 becomes 0 by design, of course. And here's our finished row echelon form. Now we have our last thing, which is this guy here. So that's minus 11/7 plus, oh, I'm sorry, minus 6 over 7 times row 3, which is minus 3. Okay, so that's minus 11 over 7 plus 18 over 7. And so that should be 7 over 7, which equals 1. And so, ta-da! Our final answer is this matrix here. We've got our row echelon form. Here's our x, here's our y, and here's our z. You don't need to know that yet. Just remember those strategies, okay? Freeze this video if you want to see the rest, but let me just go back to where we started, which is remember this, okay? Which is, here are the rules, write them, tattoo them on your hand, okay? Because you're going to see them all the time. We're going to be working this all the time. And our strategies, notice how we followed each one of these strategies, okay? So, if you got any questions, let me know, okay? Otherwise, check out the assignment that I posted on this video, because I expect to see it very soon. For those of you, of course, who are not my students, just do it, and your answers, if you need the answers, let me know, okay? Okay, thanks a lot, and take care.